In this session, we are going to see about stratified charge engines as well as fuel cell vehicle systems. First, we will move on to stratified charge engines. In this kind of engine, it will be especially used for SI engine. SI engine means gasoline types of engine. They will use a petrol. It is said to be a spark ignition engine. So, this kind of stratified charge engine is used in spark ignition engines. It is used to increase the heavy load when the truck carries or any cars or any kind of vehicles which carries heavy load. If we use these kind of stratified charge engines, it will helps in improving the thermal efficiency and also helps in consumption of low fuel. So these kind of parameters helps in stratified charge engines in SI engines, and also these things make an huge impact in real-time industrial applications. These kind of engines are used in Honda, Volkswagen and Jaguar types of cars. They will use these kind of things to reduce the fuel consumption in the engine process. So in stratified charge engine, the fuel, which is a petrol plus air fuel mixture ratio, is injected into the combustion chamber near the spark plug, so that the amount of air fuel mixture is present very high near the spark plug. Due to the spark plug, when the piston comes to the near to the top dead center, it compresses the air fuel mixture ratio with the help of the spark plug, which makes an power stroke. Due to the power stroke, the engine will run. So this air fuel mixture ratio is injected near the spark plug to increase the amount of mixture near the spark plug, and the other side of the combustion chamber, the amount of air fuel mixture is very lean. Lean means it is very low. So in this stratified charge engines, the main purpose is to increase the air fuel mixture near the spark plug of the combustion chamber. Spark plug is used only in SI engine, not in CI engine, not in diesel engines. So due to the high fuel air mixture ratio near the spark plug increases the thermal efficiency, and also it reduces the fuel consumption. So these kind of things makes more impact in the industrial development as well. And the disadvantage of using this is it will create some amount of NOx and soot particles if the stratified injection was not good. So we have to inject it at the correct timing when the piston comes near to the top dead center, so that the amount of air fuel mixture is getting near to the spark plug. Then power stroke will come into picture. After that, then the combustion process will end. So we have to inject the air fuel mixture ratio in the correct time. If we fail, then the amount of NOx production and also the soot particles will produce in the SI engine. So it will violate the BS6 norms emission control systems. So it is one of the major disadvantage in this kind of stratified charge engines. And also we have to design a separate type which helps us to inject the air fuel mixture ratio in the correct time. So these are some disadvantages in manufacturing. And then we will move on to fuel cell type vehicles. Fuel cell vehicles are work with the help of the hydrogen and oxygen. These are the basic two gases which used in fuel cell. With the help of the hydrogen and oxygen, electricity, water and heat is generated in the proper reactions. So as you can able to see in the fuel cell, the hydrogen and oxygen plays a crucial role. With the help of the hydrogen, the current is produced, and in the fuel cell you can able to see hydrogen and oxygen plays a crucial role, and also this makes an impact in the emission control also. In fuel cell, the amount of exhaust gas which is going out is zero. So the fuel cell is one of the latest technology, advanced engine technologies which is coming in industrial developments in recent days. And also in fuel cell there are many types. The first one is phosphoric acid fuel cell. In phosphoric acid cell, they will use a phosphoric acid as electrolyte. through the electrolyte the electron will not move, so that the electron will move from one node to another node in a suitable manner. And also, if we increase the temperature of the phosphoric acid, then the ion or electrons will move with the help of and the electrons will move through the ions in the electrolyte itself. So this makes an damage. So we should maintain at the correct temperature around 90 degrees Celsius for the phosphoric acid fuel cell. And then next we will move on to solid acid fuel cell. In this fuel cell they will use solid acid as an electrolyte, which makes an more impact for the fuel cell applications as well. And then we will move on to alkaline fuel cell. Alkaline fuel cell, they will use alkaline as an electrolyte. Alkaline in the sense they will use a potassium hydroxide as a electrolyte, which makes an more impact, and it should be operated at low temperature as well. So this kind of alkaline fuel cell is used in medical applications. And then if we move on to the next one, which is molten carbonate fuel cell. In molten carbonate fuel cell, they will use the appropriate electrolyte at high temperature, which is necessary in power plant systems, which gives more amount of power output. So in this more amount of power output concern, they will use molten carbonate fuel cell. So this makes an huge impact in the power industrial systems. And then the next one is solid oxide fuel cell. In the solid oxide fuel cell, it is operated with the help of the suitable electrolyte. With the help of the suitable electrolyte. In solid oxide fuel cell, they will use solid oxide as an electrolyte process, which makes an more impact in the output efficiency. In this solid oxide fuel cell, it makes and it is used in high temperature applications around 800 degrees Celsius. And also this fuel cell is used in trucks, car, buses, kind of automobiles. And also it has more efficiency, around 85% of efficiency for solid oxide fuel cell. And in this video we have seen about stratified charge engines as well as fuel cell vehicles and types. I hope this video is useful for you. Thank you.